Okay, section 5.8, analyzing graphs of, and everything in this chapter is about polynomial functions. So we're going to talk a little bit more about the graphs and use them to do an application. So one of the things you may or may not have noticed so far is that the smallest degree, and let's just review really quick, how do you find the degree of a polynomial? It is any exponent? The highest exponent, yep. So the smallest degree possible, if you're just looking at a graph, is equal to the number of turning points plus 1. I'm going to show you a couple of examples. If you're looking, number of turning points plus 1. So it's like equal to that. So couple examples would be, if I'm looking at this graph and I want to know what the smallest degree possible is, so let's just sketch a basic parabola. The turning point, there's only one turning point in this. So I'll write number of turning points equals 1. I can just tell from looking at it. Turning means it changes direction. And so the smallest degree possible for this is 2. It's 1 more than the number of turning points. The smallest degree possible is 2. We don't know yet, but that'll help us write the equation of the graph later. So let's try one more really quick. Let's just sketch a little squiggly here. How many turning points do you think there are in this graph? 2? Yep. So I'll abbreviate. When you answer the questions from the book, you can abbreviate. That is not toilet paper. That is turning points. Number of turning points is 2. And so the degree of this polynomial, if I were to, because we're going to be writing the equations for these from the graph next week, but the degree would have to be at least 3. So the degree, that means greater than or equal to 3. When I do find the equation, I know that it has to be at least degree 3. So then there's this other thing called the local minimum and maximum, which we're going to use to answer real questions in a second. So here's the definition of a local, and then you tell me why you think it's called local. It's not because it lives in Cupertino, it's something else. So a local maximum is the y-coordinate of the point higher than the nearby points. Higher than nearby points. That's a local maximum. So in this picture, the local maximum is right here. That's the local maximum. The highest point in this turn, it's on the turning point. The local maximum is here. Do you see a local minimum? The local minimum is right here. Local maximum, local minimum. Why do you think they're called local instead of just the maximum and minimum? Very good. Because the y values go down forever, so there's really no true minimum or maximum. They go down forever and up forever, so we just call them local. And they'll answer questions for us. Knowing these points, the local min or max, will answer points for us. And we're going to use the graphing calculator to find them. Later you'll use calculus to find them. So the local maximum and local minimum are important points on the, I won't write out what local minimum because it's the same thing as local maximum, except it's the minimum. So those are, yeah, Daniel? Oh, in this graph, so yeah, the local maximum is this point right here, the y-coordinate of that point, and the local minimum is that point right there. It kind of, like the vertex, yes, kind of. The only reason I don't call it a vertex is because that's reserved for parabolas. So like in this picture, if this is a parabola, then yeah, it is the vertex is the local minimum. Yeah, so it'd be that point, the local min. Yep. So I'm going to stop there. In the next 5.8 video, we'll do an application.